Good day everyone, my name is Muhammad Saiful Azmil and together with my team, we will be presenting on flow rate measurement and flow visualization for the course BMKU2613 Fluid Mechanics 1. I, Saiful Azmil, BS13231015, will begin as the first presenter. Following me, Muhammad Gaddafi, BS13231006, will continue as the second presenter. Finally, Muhammad Kamisan, BS13231005, will conclude as the last presenter. Introduction. The purpose of this study is to understand how different devices can be used to measure flow rate accurately and how visualization method can help us observe fluid motion around an aerodynamic body. The experiment used a horizontal closed-loop water channel with a transparent acrylic test section that allows direct viewing of flow movement. We will compare several types of flow meters, discuss their advantage and disadvantage, and evaluate flow visualization technique that can reveal streamlines and turbulent characteristics. Finally, we will recommend the most suitable method combination for aerodynamic research application. Water channel specification. The experiment is conducted in a closed-loop horizontal water channel featuring an 8-meter long working section with a cross-sectional size of 0.9 meters by 0.5 meters. Constructed from 25 mm thick transparent acrylic sheets, the channel allows unobstructed visual access to the flow from all angles, making it ideal for aerodynamic body testing. Fluid measurement methods. Flow rate measurement is an important part of fluid mechanic analysis, especially in experimental water channel studies. Accurate flow rate data allows researchers to determine velocity distribution, Reynolds number, pressure behavior, and drag forces acting on an aerodynamic body. Several instruments can be used to measure flow rate. Each operating use different physical principles and each having specific advantage and limitation. In our project, we focus on 4 commonly used flow rate measurement devices, which is ventrimeter, orifice plate, electromagnetic flow meter, and ultrasonic flow meter. The selection of these devices depends on cost, accuracy, installation, condition, and fluid behavior inside water channel. Visualization methods. Understanding how fluid moves around an aerodynamic body requires effective visualization method. Several techniques can be applied to make flow pattern visible, ranging from simple qualitative approach to advanced quantitative systems. In this section, we will highlight the key visualization methods before evaluating their strength and weakness.
Good day everyone, my name is Muhammad Gaddafi bin Zaini with metric number BS13231006. I will be presenting the second part of the presentation, which focus on the flow rate measurement method used in the water channel experiment. A ventrimeter is a device that measures flow rate by using a converging diverging pipe section. When the fluid enters the no-rate-through area, is a velocity increase and the pressure drop. By applying Bernoulli equation on the pressure difference between the inlet through, the flow rate can be calculated. Advantage: high accuracy, low energy loss. Disadvantage: expensive, requirement permanent installation. Orifice plate. An orifice plate measures flow rate by placing a flat plate with a circular hole inside the pipe. This creates a sudden restriction that causes a pressure drop. The pressure difference is used to calculate flow velocity using Bernoulli equation. Advantage: low cost, easy installation. Disadvantage: high pressure loss, lower accuracy. Electromagnetic flow meter. An electromagnetic flow meter measures the flow rate of conductive fluid using Faraday's law of induction. When a conductive liquid passes through a magnetic field inside the meter, a voltage is induced. The voltage level is directly proportional to flow velocity. Advantage: very high accuracy, no pressure loss, no intrusive. Disadvantage: high cost, require electric power. Ultrasonic flow meter. The device works by sending ultrasonic sound wave across the flowing liquid. Two transducers measure the time difference between waves moving upstream and downstream. The time difference indicates flow velocity. Advantage: portable, non-intrusive. Disadvantage: sensitive to bubble and alignment issue. Dye injection visualization flow by introducing color dye into the water stream. As the dye travels along the flow direction, students can be clearly see streamlines, laminar smoothness, and flow direction. Advantage: low cost, clear visualization for laminar flow. Disadvantage: limited effectiveness in the turbulent flow. Particle image velocimetry (PIV). PIV use small particles added into the flow and high-speed camera system. A laser sheet illuminates the particle and computer software measure the displacement between frames to generate velocity field. Advantage: provide detailed, quantitative velocity field. Disadvantage: very expensive, complex setup. Hydrogen bubble technique. In this technique, a fine wire produces tiny hydrogen bubbles through electrolysis. The bubbles follow the water path, forming thin visual streamlines around the test object. Advantage: excellent for boundary layer studies. Disadvantage: complex setup, safety concern. Turf method. Short thread turf are attached to the surface of the object. The way these threads move show flow direction and separation. Advantage: simple, inexpensive. Disadvantage: only qualitative results.
Hi, I'm Muhammad Kamisan bin Zaini. I will present about suggestion and recommendation. Before finalizing our recommendation, we carefully review several alternative techniques for both flow rate measurement and flow visualization. For flow rate, the Venturi meter was considered for its high accuracy, but its cost and installation complexity made it less practical. The orifice plate offered a low-cost solution, though it came with reduced precision and significant pressure loss. The ultrasonic flow meter was attractive for its portability and non-intrusive design, but its sensitivity to bubbles and alignment issue posed limitation. For flow visualization, we evaluate the hydrogen bubble method, which is high effective for studying boundary layers but requires a complex setup and safety precaution. The turf method was also considered due to its simplicity and affordability, though it only provides basic qualitative insight. These techniques were valuable to explore, but after weighing their advantage and limitation, we selected the most suitable combination based on accuracy, practicality, and compatibility with our experimental setup. For accurate flow rate measurement in our experiment, we recommend using an electromagnetic flow meter. This device operates based on Faraday's law of electromagnetic induction, allowing it to measure flow without any moving parts. It offers high precision, introduces no pressure loss, and does not disturb the flow, making it ideal for aerodynamic body testing in water channel. Its non-intrusive design also complements the transparent acrylic setup, ensuring clear observation while maintaining reliable performance under various flow conditions. For flow visualization, we recommend combining dye injection with particle image velocimetry (PIV). Dye injection is a simple and cost-effective method that helps reveal basic flow patterns, making it useful for initial observation. PIV, on the other hand, provides detailed and quantitative data by tracking tracer particles illuminated by a laser sheet. This technique allows for precise velocity field analysis. By using both methods together, we achieve a balance between practicality and precision, ensuring clear visual results and reliable data for aerodynamic body experiment. In conclusion, the choice of instrumentation plays a critical role in fluid mechanic experiment. By using an electromagnetic flow meter for flow rate measurement and combining dye injection with PIV for visualization, we can achieve accurate, reliable, and analyzable data. This approach ensures that the aerodynamic body experiment in the water channel produce results that are both scientifically valid and educationally valuable.